Alright, so pretty much, we're gonna look at the fun part of the physics where this is concerned. I'm gonna skip some part of the questions. I'm gonna look at this part. We're gonna calculate the tension here in the string. So this is what we have. By right, I have a string, and pretty much it is being pulled downward. And it's gonna have some mass times gravity being pulled down, and then I take another force and I pull on this string and on the mass, and what we end up is this scenario here, this scenario where pretty much it's gonna be at an angle of theta to the thing. Alright, so pretty much the question is asking you, what would be the tension? What's the value of the tension in the spring, in the string? Actually, this one's called a spring. So alright, now the method they use here is gonna be Pythagoras' theorem. But we're gonna use a different method. Want to see my method? Hello?
Yes, sir.
My method is gonna be harder though. Not really. Alright, let's look at their method. They use what we call a tail to tip method. What they did, they connected they draw pretty much a Venn diagram. So what they did, we have a force, this diagonal force going upwards in this way, and they put it here. We have this force that going that way, they put that there, and they have that force. So what they wanted to do is to complete a shape, and that's one method we could use to solve this question. And what they did now was to go ahead and find the hypotenuse. So we know using Pythagoras theorem, let's call this O, let's call this A, let's call this B. We would say that OB squared is equal to AO squared plus AB squared. So using that method, we end up with AO is gonna be equal to your weight, and we know your weight is gonna be equal to pretty much 5 newtons squared, and it's gonna be equal to 3.5 newtons squared, and therefore you're gonna end up with, just add these two together and you need to find the square root to get OB. Now we end up with 5.9 newtons. That's one method of how to do that. Alright, make a note of that. That would not be my method of working it out, but make a note of that. Alright. Are you guys ready for my method? Awesome. Alright, my method of working this out. The method that I just worked out was that method. What I would think Now this system is in terms of it's in equilibrium, meaning that the system is not being moved. So what's gonna happen is that equal forces, you have equal and opposite forces acting on the system. So by right, there's a downward force and there's also an upward force going up. And this upward force, we're going to talk about what it is. And there's a force, so there's a downward force of weight and there's a upward force, and it's T something. I'm going to talk about what it is later on. There's also a force that is going in this direction, and these forces are balance forces. Although T is heading this way, I can actually have a horizontal component for T, and I can actually have horizontal component for T, and I can actually have a vertical component for T. So since they want me to find T, I'm gonna use this plane, the upward and downward. But I need to know if I'm gonna use sine or cos. So I'm gonna complete this and draw a triangle, right angle triangle. This would have been my opposite, and this would have been my adjacent. So pretty much I want my adjacent side, and I know the hypotenuse. So if you're looking at adjacent and hypotenuse, you're gonna say cos theta is equal to adjacent over what adjacent. What happened? What's happening here? Adjacent over hypotenuse. So in order to find this now, the force that is going upward will actually have a vector or a value of T cos theta. Oh, they don't tell what theta is. Later on, Barrett, I think I jumped the gun. So what we could do, oh, they didn't tell what theta is. Okay. What we could do, you could say T cos theta is equal to mg. And if they told us what theta was, we could have found that. Oh, they have to define theta afterwards. I guess that's always that method. Jump the gun. Like I really want to go in and teach this topic. I don't know why. I guess I jumped the gun with that question and then you guys get away. Leave to see another day. Well, I guess not. Alright, so we're gonna use that principle and solve these equations. You guys remember this topic from CXC days? Moment? Alright, so we know that moment, so we're looking at linear. The moment of a force is defined as the product of the force times the perpendicular distance. So normally we're gonna say moment is equal to force times distance. And make a note of that. We're gonna come across that a lot. And it's taken about a point. And when we look at moments, we're looking at turning effort, how something will turn. And we're gonna look at why we say it's perpendicular distance as well. So make a note of what moment is. Give an intro to that in your book, and then we're gonna move forward. Alright. Now I'm sure you guys got that. Ooh. Now we're gonna look at the principle of moment. I'm gonna teach you like you know it. And maybe we have to suffer a bit because of it. Principle of moment means that the clockwise moment is equal to sum of the anti-clockwise moment. And let me take it from the basic before I abuse you guys. Although I want to, but I'm not going to. Alright, so this is the scenario we normally look at in terms of moment and the principle. I'm going to skip right into we normally have a seesaw. And we normally it's gonna be in equilibrium. So what's gonna happen is that it's gonna have a force on this side and it's gonna have a force on that side. And it will be from a distance. I'm gonna call this F2. I'm gonna give the value of 3 newtons and I'm gonna say this is gonna be D2. I'm gonna give it 2 meters. I don't know what F1 is. And let me give you D1. D1, let's say argument D1 is 5 meters. And so this thing is balanced. And we need to find the value of F1 using the principle of moment. So find the value of F1 using the principle of moments. Given that the ruler is balanced. Alright. So what we can say sum of, this is a principle, sum of, I'm gonna write it in words first. It's not, why am I'm lagging like, whoa. Give me a second, let me close down something. I am lagging. And I don't even know why. Alright. That should be okay. Okay. So we're gonna say sum of clockwise movements is equal to sum of anti-clockwise movements. Alright. In terms of symbols, I like to use, this is gonna be summation symbol. It may not look like this. I think the summation symbol looks more like this. Sum of clockwise movement is equal to sum of, you can Google this, anti-clockwise movement. Now, which one is going to be clockwise and which one is going to be anti-clockwise? And what is clockwise? Clockwise would be if I'm going to pull down on this here. Pull this down on this here and there's a pivot or a door and I pull it, the door is going to swing this way. So I'm pulling this way, I'm ignoring this other force. And what's going to happen is that F1 will cause it to spin clockwise. So F1 times D1. Now, when I pull down here, say there's an inch there, and I pull this way, F2 will cause it to spin anti-clockwise. So I'm going to put that there. And I just need to find F1, so that's going to be our unknown. So I said that F2 is 3. Is 3. D2 is 2. F1 is what we don't know, and D1 is 5. So we're going to put 6 F1. So therefore, we're going to have F1 is equal to 6 over 5 newtons. So I should know that out of my head. 6 over 5. I will end up with 1.2 newtons. So F1 need to be 1.2 newtons to have that system in equilibrium. Take that one down, and then we're going to move on to another one. All right. Now, what I'm gonna do something. I'm gonna insult your intelligence. Are you guys ready to be your intelligence to be insulted? Hello? All right. I'm gonna insult your intelligence, and I'm gonna change one something. I'm gonna change the numbers and ask you now to calculate something. Same question. You're gonna try. I'm gonna make this equal to 10. F2 equal 10. Make this equal 5. May I make this equal to 3? And no. Now make this equal to 3. It's not gonna be equal to 3. This is what I don't know. This is what I don't know. And make this equal to 12 newtons. So find for me the value of D1. So that's an insult to your intelligence. Find for me the value of D1 in only 2 minutes, and then let me know how we stay. All right. See, somebody answered me. Uh, so that was an insult to your intelligence. Um, we could we don't give so much decimal places. We start off. Let's try give to 1. But Barrett, we should have given to a whole number. All right. So this would have been F2 is gonna be 10 times 5 is equal to 12 times D1. This is going to be 50 is equal to 12 D1. So we're going to have 50 divided by 12. And I don't know the answer for this. I don't know why I divided 50 by something. And we'll call it, let's call it 1.47 newtons. And that's easy peasy lemon squeezy until that doesn't even mean I'm literally setting it up. Let me see something. If I have a question with oomph. Ooh, I found a question with oomph. Just a little bit of oomph. Alright, cool. So there's another condition. Alright, so this question is a nice question. Nice wheelbarrow question. So what CXC realize, Cape CXC same thing to me. Realize that students kind of don't really apply themselves. So instead of we normally give fees on, then it easy and nice. Then we said no. We want you guys to suffer a bit. Because sufferation is good. Question is simplified version. Find the value of P. That's one. Find the value of R. Given that the system is balanced. All right. This is simplified version of the question. All right. Whew. That's rough. Now notice that we don't know the point of rotation. But we're gonna pick this point of rotation. Don't ask why. We're gonna pick this point as our point of rotation. Normally, we pick the point of rotation from any of the forces, and we can pretend like all the forces are on one line, because based on the definition of moments, it is the force times the perpendicular distance. So it's gonna be force times here, so that's gonna be perpendicular. That's gonna be perpendicular. So we can pretend all this is on one line. Just know that all the way up here, so and slant like this, we can pretend like it's on one line for this one. Alright, so we're gonna pick this point as my pivot. So I'm gonna say, and the point where I pick as my pivot, that force won't play any role in it. Because the distance from this point to that point, so if I look at the moment that is at R, from this point here, is gonna be whatever R is times 0, and that's gonna be 0, so it's not gonna play a part in the equation. So I'm gonna have sum of clockwise movement is equal to sum of anti-clockwise movement. Now, looking on P, so this is going to be my point of rotation, and look on P and I pull it up this way, P would want it to rotate anti-clockwise. So let me just call this, I can call this P, just call it P times what we'll call D1, it could be D1, and therefore this is going to be the weight of an object that's at the center of gravity. I know it's the center of gravity because I know the question. So it's going to be W times D2. So instead of F1 and F2, we're just going to use the letters that CXC gave us. Now, some students like to use applied denseness and take the distance from here to here, and then I take the distance from here to here. All distances are taken from the same place. And I told you that all distances are going to take in right here. So this line here. So when you look at P, you're going to look at the distance from P to the point of rotation you chose. And the point of rotation you chose for P is going to be 0.6 plus 0.8. So it's going to be P times 0.6 plus 0.8 give me 1.4, right? And then for W, which is going to be your weight, is going to be the distance from here to that, and W is 480 times 0.6. So we're going to end up with 1.4 P end up with, give me a second. is. So we divide both sides by 1.4 and we end up with P. Malik Lynch, is this right? Are you in the right class? Malik? Okay. And that's the value of P. And that's how you would have done that question. Same question as
This
if
is physics.
wrong class, Malik. This is K physics. Later. Alright.
So sir, can I get a re-lecturing?
Malik, I'm in a class. Can you leave my class, please? I'll talk to you another time. Send me a WhatsApp message.
Yes, sir.
Alright. Alright. Look at that. Take that down. Alright, you ready for part two? Part two, we're gonna use another condition for equilibrium. But you didn't tell me one. Yeah, there are two conditions for equilibrium. One is that your um clockwise is equal to anti-clockwise, and the second condition for equilibrium is sum of upward forces equals sum of downward forces. Well, this is upward and opposite forces. Yeah, opposite forces are equal and opposite. Sum of upward forces. It could be sideways, it could be left and right. Upward forces equal to sum of downward forces. Upward forces, we have two upward forces. We're gonna have R plus P is gonna be equal to W. We know P, we just found P to be 205.71 is equal to 480, and that's gonna be R. Therefore, R would have been equal to 480 minus 205.71, and that would have been equal to that. So that is the other condition. And I know you're thinking this is too easy. This is K. It does get harder. So, tear that down. Newtons. So that would have been the value of R. And that would have answered those two questions. Alright, take that down and thumbs up when you're ready. Alright, thumbs up, you guys. Thumbs up, ready? For question 2. Hello? I think you're ready. Alright, let me find a memory question. That's it? Sure. I just I just typed in moment in my thing and I saw nothing come up. I thought I had you guys ready. Calculate. Give me a second. Calculation for a. Oh, alright. Good news, bad news. I have no more questions to give you. I thought I had questions ready, but don't worry. I got you. I got you. Oh no! I have several questions. Is that I thought that past paper booklet had one. Um. Ooh. I found a book. Let me show you. I have to make. You guys have to enjoy the physics, you know. I have to give you the physics of oomph. I just swear I had this book on my laptop. It's online. This is my online version. This is a version with these are questions with oomph in it. Look at that. Beautiful. Beautiful. Where should I start you off with? Which one I want? You want, you know, anything but that one here. Example 7. Example 7 look like a beautiful question, don't it? Alright. Let me just put this in my paint. You guys are excited. This is a question. This is a beautiful question. Amazon. Alright. Let me get it off the question to scratch. I got the question for you guys. I have questions for this. Now look at this question. Apart from leaving it alone, take it down. We're gonna salivate on the question. Beautiful question. Take it down, and we're gonna get to it. It's a very beautiful question. All right. Anybody have any ideas? Thumbs up, thumbs down. What's it? Hello? If you saw this question only on the exam and you needed this question to pass, keep physics. What would you do? Hello? I need to leave the room and come back. Um, Kellan, if I see this question and it's the only question you need to pass on the exam, what would you do?
So just accept defeat.
Obstacle fate, that's an easy question, and you'll be getting deals. I like that, Kellan. I like that. Good look. So, the question asks us to find the force. Clearly, it's a moment question. So we're gonna say sum of, and sum of means add. Sum of clockwise moment is equal to sum of anti-clockwise moment. So we're gonna look at every single force we're looking on and find our pivot. I'm assuming that we all have arms. Therefore, we know our point of rotation is right here. I'm assuming that. We all know that, right? Hello? You know that, right? Yeah, I've seen all of arms. Then we're gonna have one force. This is one force. We have another force, two force, and we have three forces, which is some we always have. So let's look at what force would cause it to clockwise. Now your muscle, if you have a hand, you can do this. You can try to see what direction. If the muscle is gonna go up and it's gonna rotate about your ball joint, it's gonna want to rotate this way. So it's gonna rotate up and go back that way. Therefore, this force of T is gonna rotate anti-clockwise. So it's gonna belong on this side. So T, let's call this, I call it D1, no matter. Let's see what another force. That's one force. Next force is this one. Force 2, that's the weight of the forearm. Weight of the forearm. If you have a hand, you can do it. You can drop your forearm and notice that the direction your forearm will rotate. Therefore, the forearm will want to rotate this direction. If you want to rotate that direction, that's clockwise. So the weight of the forearm times the distance. And then there's another force, force 3. Force 3 on its own is going to want to weigh down the arm, and therefore it also will cause the arm to rotate in a clockwise direction. Oh, I didn't accompany anything. So you have to look at the force times distance for all forces in the system. So it's going to be, let's call this times D2 plus, let's call this our mass. Let's call this Fm times D3. And that's the equation. So moments is sum of clockwise moments. So these two, that one here, I'm putting already, we never see it. That one here, that is causing the arm, the weight of the arm itself. We want to rotate it clockwise. and this one wants to rotate clockwise, so I'm gonna add them, which is this. The moment is equal to the force, the weight of the arm times the distance, and the weight of the ball times the distance is equal to the muscle. So the muscle is only tough. And that is that. I guess this is the first time you guys are seeing a question with more than one force acting on a body. Don't worry. When I did CXC, a 5 force a man and put on my something there. And this when I did CSEC, a 5 force a man and put on my one. 5. So the escape question is a breeze. Alright. So let's put in the numbers. The weight. So we know that the weight of the arm is 1.4. The mass of the arm is 1.4. So the weight is going to be 14 newtons. The distance is from always from to the ball joint. So it's going to be 18. So it's going to be distance from here to here. And that's 0.18. Plus the mass of the ball is 2. Therefore, it is going to have 20 Newton force. Times the distance to the ball joint. Some silly students might take the distance, go here, so the distance is from here to here. Everybody's taking the distance from the ball joint. Only stupid students will take any other distance, which is gonna be 0.36. We don't know the tension, and the distance is from here, where the tension is perpendicular to here, and we told that it was 0.0, so it's gonna be 0.060. So I'll put that max there. So all forces are taken from about the same point. Not rubbish. So we're gonna multiply this. So it's gonna be 7.2 and it's gonna be 2 point that. So it's gonna be, oh, I forgot T. So it's gonna be 9.2, 9.7 to write it properly. And this is a question with oomph. Well, it gets better now. It gets better. Oh yeah, Unit 2 is easier than Unit 1 for all my second year people. We end up with 162 newtons, and that would be that would have been the tension in the muscle. What's my scale? Get that done. All right, people, are you ready? Hello? Hello? All right. You're not here looking at something? All right. Anyway, I'm gonna skip out that other part of the force. I don't think it makes sense. Amazon. Ready for the next question? Here is another beautiful question. Here's another beautiful question. If you saw this question on your Cape paper, only question you need to answer to pass, what would you do? Look at the question and then let's try. Beautiful question. All right. Now you guys look at the question and salivating like wonderful question. Like where did Mr. Sir find this question? Clearly, it's a top-notch question. All right. You see this question? What would you do? White. You see this question? What would you do if you see this question?
Attempt it to.
All right. So we're gonna attempt it. So calculate the magnitude of F. So now we have how much forces. Let's count our forces. How much forces we have, and we need to know if it's clockwise or anti-clockwise. We have F is right here. What's one force? We have another force at B. That's two force, and we have three forces. Nothing new. We did something like this already. So we can say clockwise movement. Clockwise movement is equal to the sum of anti-clockwise movement. So let's see. This is our pivot. So therefore, if I push down on this here, it's gonna want to spin this way. It's gonna want to spin that way. And if I want to spin that way, we know that F is gonna be on the anti-clockwise side. So let's say F times D1. It doesn't matter what we call it, D1, D2, D3, don't care. And since this is on the same side, D, when I push it down this way, it's gonna want to spin that way. If I want to call it D, let's call it B. B times D2. Nobody want erase that out and make them a book, good. Plus B times D2. And then W is gonna cause it to spin clockwise. It's gonna be W times D3. So it's gonna be force times distance. And everybody is gonna be taken from this point here. That's the point. So looking at F, we don't know F, so right back F, and let's look at the distance from the pivot. The distance from pivot to F is going to be this, so it's going to be 0.6, so it's going to be 0.6. B had a value of, in terms of, I'm going to bracket this, 0.20 times the distance from the pivot to it is going to be 0.2. W We know the this is wrong. This is gonna be kilo. My bad. Alright, I'll just put that at the end. This is gonna be 1 times 0.02. So this give me 0.02 equal to 6.f plus, can I get negative first? Same thing. Okay. I end up with 0.04. I have to subtract this now. 0.02 minus 0.04 is equal to 0.06f minus 0.2. This gives me divide both sides, and whatever I get, that's f. This is 0.67 kilonewtons. Because it was in kilonewtons, I didn't express it in kilonewtons. So that's how I approach that question. Easy peasy, lemon squeezy. And you know, when I think that you figure it out, I'm gonna switch it up on you again. Because I am that type of person. Sorry. Alright, OST. Alright. The reaction force, the first one. Ooh, that no. So what happens is that here, because all these three forces are pushing downward on the board, there's an upward force here. There's an upward force right here, called a reaction force. So you could say sum of downward force is equal to sum of upward force. And we have three downward force. We had F plus B plus W is going to be equal to R. I think it's R. So this is going to be 0 point plus 0 point plus 1. And that's going to be equal to R. So R is equal to 1.47 newtons. And that's easy peasy lemon squeezy. Obviously. Oh, I'm gonna give one more. Then we go tomorrow. What time we want to meet for tomorrow class? We can meet 1 o'clock online. We're like Raina Fall. 1 o'clock online is good.
Yes, sir, if we have light.
Brother, would everybody have solar? Light is so basic.
Sir, 1 o'clock can't work.
Why? Where will you be?
Sir, so my teacher them talk about we have class and we have things to do.
But normally my time is 1 o'clock. So how are you gonna give somebody else my time?
Your time is 1 o'clock. No, sir.
What time is my time? 2 o'clock?
1 o'clock school. 1 o'clock we have our next class.